Hi guys, welcome back to the AceCoder Academy. So today we will be discussing this problem from the LeetCode, which is Stone Game 2. So this is the 20-second problem of the dynamic programming series. So if you haven't watched the previous videos, you can definitely consider watching them since it will be really helpful for you to understand the concepts in the upcoming videos. And if it's first time that you're visiting my channel, you can definitely consider subscribing it and pressing the bell icon so that you don't miss any of the upcoming updates. So let's get back to the problem. So firstly, this question is actually a slight variation of the Stone Game 1 problem. So we have already solved that problem and I'll attach the link to it in the description as well as in the top right corner. Firstly, you can click on that and watch that solution, and then the solution to this problem in this video will completely make sense to you. So let's get started with this problem. So the question states that Alice and Bob continue the games with piles of stones, and there are number of piles arranged in a row, and each pile has a positive integer, that is the number of stones. So actually we are given an array, and each index of that array, what does it represent is the value on that index simply represents the total number of stones in that particular pile, and the objective of the game is to end with the most stones. So now the rules of the game are that there are two players, Alice and Bob, and the first turn is of Alice. And then there are two variables, namely M and X. So now let's see what they both represent. So initially M will be equal to 1, and on turn, each player's turn, that player can take all the stones in the first X remaining piles, and this X will vary from 1 to the double of M. So in this case, if M is equal to 1, so the first player has a choice either to choose only a single stone or double stones from the starting of that pile. And then we can set M is equal to maximum of M and X. So this game will continue, and alternatively turn will switch. The game continues till all the stones have been taken. And assuming that Alice also aims that she has the maximum stones, and simply Bob also aims to have the maximum number of stones, we have to return the maximum number of stones that Alice can get. So I hope you have understood this problem. So now let's have a look at some test cases. So here we are given this array, and each element in this array represents the total number of stones in that particular pile. And we have two players, namely Alice and Bob. So what other things that we are given is that initially M is 1, and the variable X varies from 1 up till twice of M. And M is represented as the maximum of X that we have chosen and the previous M. So this is the information that we are given. And since first turn is of Alice, so Alice has actually two options because initially the M is 1, and Alice has two options, which are she can choose either single or two heaps. So she has two options. So let's consider that she chooses these two heaps because X varies from 1 till 2 in this case. So the total stones Alice has is 2, 7. And now this M will be updated to 2, 1. So out of 2 and 1, which is bigger, it is actually 2. So now M will become 2 because after this step we have to check this one because X we have selected is actually this 2. So that is the reason X here is 2. So now the turn is of Bob, and the total number of heaps left are only these ones. And now Bob has an option to choose between 1 up till twice of M, which is actually 2. which becomes 4. So Bob has option that either he can choose 1, 2, or 3. If there would have been another element also, then he had the choice to choose that element too. So let's consider that in this case, Bob chooses 9, 4, and 4. So he selects all these three elements. And now, if we see the total, that the total for the Alice is actually 9, and the total for Bob is actually, which is 17. Yes. So the total number of stones that Alice has is 9 and Bob has is 17. So in this case, the maximum stones that Alice could obtain was actually 9. But we have to, since we know that, because both are playing optimally and they are making sure that both of them win. So actually, this is not the optimal way of selecting all the elements. So now let's have a look. How should Alice choose such that she has the maximum number of stones? So she decides that firstly, she will choose only 2. So in the first turn, she has total number of stones is 2. And in the next turn, the value of m will be maximum of x and m. Since x she chose is only single, which is 1, so this m will be the maximum of 1 and the previous m, which was already 1. So this m will be 1 in this case for the Bob. So now Bob has option again to choose an x which varies from 1 till twice of m, which is basically 2. So either Bob can choose single or double. So since he is also playing optimally, so what will he try is that he'll choose all the stones. So now the total stones Bob has is basically 7 and 9. So the total stones that are left with Alice are 4 and 4. So this is only the heap that is left. So out of 4 and 4, now M will change to the maximum of 2 and 1. Why 2? Because previously Bob chose 2 heaps. So that is the reason. X is 2 in this case. So M will become 2 for the case where Alice has to choose. So now she will choose all all the piles left, which are basically only 2, 4 and 4. So the total number of stones now with Alice are actually 10, and that with Bob are 16. So if we compare it with the previous approach, which had actually 9 stones, so in this case, we come to know that actually this is the optimal way in which Alice will play to obtain the maximum number of stones, and the maximum number of stones that are equal to 10. So we have verified our answer. So now let's have a look at how can we approach to this problem in a brute force manner. So now, in order to think of a brute force approach, one thing that we need to realize is actually this problem can be further broken down into sub-problems. Hence, the recursive code would suffice. And now, once we have found out that recursive code will work, then what all functionalities are actually required in that recursive code? So let's see that. So firstly, the first thing that we observe is actually whenever the X is varying, always the stones are being selected from the front, and there is some heaps remaining. And after this step, this might be the case that only these heaps are remaining. So one thing is for sure that we need a single variable that will like iterate from the start till the end. This will tell us actually, like for example, if this particular variable is here, so this will tell us actually that only this is the heap that is actually left, and we need to perform all our operations on these heaps. So first variable is this one. to check size of current heap. So first is this. What is the second? So now for every heap that we have got, we need to iterate over it. Why? Because this x will be varying from 1 to twice of m. So for example, if this is the total heaps that we are given, then we have a choice that either we can select one or two. And what we are actually doing, we are simply iterating this x. So another for loop is required for this part, for loop. And what is the third thing actually that is required? The third thing that is required is that we need to know actually whose turn is it. So whether, for example, only this part of the heap is left. So now if we have to perform this operation of iterating this x, then actually who is iterating it? Whether is it Alice or is it Bob? Because we have to return the maximum number of stones that Alice can get, right? So we will be focusing on this. So actually these are the only three functionalities that are required in a recursive code. So now let's implement these. So firstly, we will create a variable n, which is representing the length of the piles. So I have just renamed it to a and a dot length. And next what we will do is we'll create a sum array which will represent the total prefix sum. What actually our aim is, we just need to find out, for example, if this is the set of stones that like Alice has chosen. So actually what is the sum? So every time we should not iterate over all these indices to calculate their sum. So we can just do it in O of 1 operation by calculating the prefix sum. So that is what this sum array is for. And we will simply iterate over it, and if I is equal to 0, then we will simply initialize it with a of I, or else what we shall do is sum of I is equal to sum of I minus 1 plus a of I. So this is where we have initialized this sum array, and now we will create a new function which is query, where we will be simply given input as left and right, and we will also parse this array sum. So now what will it return is, actually it will just return the sum of all the stones between the range and R inclusive. And we just need to write one condition that if L is equal to 0, we can simply return sum of R, or else return sum of R minus sum of L minus 1. So this is, we have here we have created a query function, and now what we will do is we will now work upon our recursive code. So let's create a recursive code as public int function, and the parameters of this function are int a, which represents the array, which is basically all the heaps that we are given, and int m, which actually represents the current m that is given to us, and int index. This represents the particular index that we are currently standing on. For example, these two heaps have already been taken out by any of the players, and now only these heaps are left. So out of them, index will point to this one. And this clearly shows that this index, the all the heaps after this index are left. So this is what this index variable represents. And then we have integer variable as turn, which actually represents like whose turn is it. And lastly, int sum array. This sum array is actually the prefix sum that we have calculated here, and this will help us in querying, right? So the first step that we need to do in this recursive function is that if our index is actually greater than or equal to a dot length, which is actually the total length of the heap that we are given. So it clearly means that there is actually no heap left from which stones can be selected. So we will simply return 0 here. And now we have a turn variable. So what does it actually represent? Like if turn is equal to 1, then it means that it is Alice's turn. And in case this turn is 2, then it is Bob's turn. And they will be changing their turns alternatively. So now we have if loop, that if turn is equal to 1, then what shall we do? And else case, if it is like turn is equal to 2. So in this case, what shall we do? So here are two cases. So firstly, just let me write the for loops for both of them, because eventually they have to iterate for x between 1 to twice of m. So it we have created integer I is equal to index, and this I will be less than index plus 2 star m, and the other condition is that this I should be less than a dot length and I plus plus. So this is for Alice, and similar for loop will work for Bob. So now here comes an important concept which we discussed in Stone Game 1 problem solution also. So what is that? Actually, let's consider that these are the set of stones that we are given regardless of whatever their value is, right? And we have x for a particular, let's say for Alice, and this x varies from 1 to 4. What does it mean? It actually means that Alice can select either 1 or these 2, 3, or these 4 piles, and whatever here the numbers might be. Let's say 1, 3, 9, 8, 4, 6, right? So whatever here the numbers might be. So what will her approach will be? So her approach will be that, for example, if she selects this pile, then the total number of stones is increased by 1 plus. Then she will call this recursive function on this range, right? And similarly, what will she do next time? She will simply select these two stones, and their total will be 1 plus 3, 1 plus 3. And what she will do is that she will again call recursive function on this range. So similarly, all these cases will happen that in the next time, what will she do is she will simply select 3 stones, 1 plus 3 plus 9, plus she will call function on this part of range. So out of these 3, the one that is maximum, she will select that only. So this is the case for Alice. How she will play optimally and maximize her chances of getting the maximum number of stones. So this is how Alice should play optimally. And if we are actually counting the stones only for Alice, then if it is Bob's turn, then what will happen is, let's say again we are given these stones 8, 4, 6. So let's say she selected these two stones and only these stones are left. So again, this X is varying from up till 4. So now what will Bob do is, if he says that he takes this one and out of this range, what will he do is he'll count his stones as 9 plus function. He will also try to maximize, but since we are only calculating the stones for Alice here, we will simply ignore this 9 stones, and what other we can do is Bob will try that I should return that answer which actually returns the minimum value, which leaves the minimum scope for Alice to choose the stones. So out of this range and this range and again this range. So what will Bob try to do is actually he will try to leave the minimum chance that Alice can choose the maximum number of stones out of that range. So we just need to keep this part in mind. So now let's continue here and let's create an answer variable, and this answer will be maximum of answer, and again this function is called. So firstly we will just run a query, and this query will run from, it will be run on some prefix array that we have created, and it will go up from index up till I, and we will simply increase this plus. Now this function will be called from array A, and then we will simply write math dot max, which actually represents the particular x that we have selected, which is actually I minus index plus 1 and the particular m. So because in the question we are given that we should update this m as maximum of m and x, so this is the m and this is the x that we have chosen. So we have updated this m as maximum, and now we will simply increase the index to I plus 1, and the next that we need to do is that because the next turn is of Bob, so we will just write 2 here because 2 represents the next turn is of Bob, and after that we will simply enter this sum. Yes, and here we can return this answer. And now what we will do here is, it is similar, but the only thing is that we will eliminate this query because we are not counting the total number of stones for Bob. We are just counting for Alice. And in this case, what will Bob try to do is he will try to leave the minimum scope, not maximum. So this is actually very important in this part, that he will leave the minimum scope for Alice to choose. So we will create answer variable is equal to integer dot max value, and then this will work, and we will apply just this condition that if answer is equal to integer dot max value, then we will update our answer to 0, and here we will simply return our answer. So let's see if this code is working, and here we need to just call this function as well in the main function that we are given. We will simply return function array A, and the next parameters that we are given is m, which is actually 1 initially, the index is 0 initially, and the turn is of Alice because first one is of Alice, and we have sum. So let's try to run this code. So we are getting an error which is actually in the query. And the query, okay, so it should be sum first, int sum. Yes. So the reason that we are getting wrong answer is actually when turn is equal to 1, which is actually of Alice, then we should call the function for the next turn, which is of Bob. So here we updated this to 2. But when it is Bob's turn, we forgot to update it as 1 because next turn will come for Alice. So now let's try to run this code again. Yes, so now it is working correctly. So this should definitely give time limit exceeded. So let's see. Yes, it is giving us time limit exceeded because obviously it is recursive code. So now let's see how can we optimize our code. So while we were finding out the intuition to this problem, we wrote these three important factors on which our recursive code will depend upon. So actually these are only the states of the DP that will be created. So firstly, it is to check the size of the current heap. So for this, we created an index variable, int. And in this case, we have applied a for loop. Now, if we consider this x and clearly analyze that is this x is also actually dependent on this m. So the next factor is this m variable. And lastly, whether is it turn of Alice or Bob. So the third variable is actually this turn variable. So these are the states of this DP. So now let's pass this DP array and return the already pre-calculated answers. Firstly, we will create new int and the size will be for this index because its size will be n. We will pass n here, and for this m we will take as n, and for this turn because this turn is only 1 and 2 we will take size as 3. So now we will create this DP array here also in DP, and here we will check that in case if DP of it is index and m and turn, if it is not equal to 0, then we can simply return this as DP of int m and turn, and here we'll simply initialize this, and here also. Now let's look if our code is working fine. So yes, here we will get an error that we have not passed this DP into the function that we have called. Let's try it again. Yes, it is working fine. Now let's try to submit this. So actually index one out of bounds exception. So actually the reason why we are getting index one out of bound exception is because the size of m should be +1 because initially m is 1. So we are just taking 1 based indexing. So that is the reason. So now let's try to submit this. Yes, now it is working correctly. So the time complexity for this will be actually n cross, which is n+1. I'll treat it as n cross 3. So actually if we clearly analyze this, it is actually n square. So this is the time complexity for this solution. So I hope you understood solution to this problem in this video. And if you appreciate my work, you can consider subscribing to my channel and giving thumbs up to this video. So let's meet in the next video. Till then, bye bye.